Have you ever stopped to think about what's actually going on when you connect to a network, maybe from a coffee shop or the airport? It really seems like magic, but it's not. It's a whole system of security layers, and each one has a very specific job to do. Today, we're going to peel back those layers. We'll start with a super simple digital hello and build all the way up to creating a secure, private tunnel just for our data. So, let's dive in. Oh, and a quick heads up, if you really want to get into the weeds on any of this, all the source material and links are waiting for you down in the description. All right, so here's our game plan. We're going to start with the network's basic toolbox. Then, we'll talk about that simple "Are you there?" protocol. From there, we'll get into building digital tunnels. Then, figure out how to secure them with something called the IPsec stack. And finally, we'll look at how you choose the right kind of digital armor for the job. So let's start at the very beginning. It really helps to think of the internet as this massive collection of specialized tools. I mean, it's for way more than just loading up websites. Networks use this whole suite of protocols. It's like a secret language, really, for all sorts of jobs, like running diagnostics and, of course, building secure connections. So what's the very first, most basic tool in that whole toolbox? Well, it's the one that lets us do a simple digital handshake, just to see if there's anyone listening on the other side. I mean, it's a question network admins ask themselves all day, every day. Before you can do anything complex, you have to answer this one simple thing. Is that server, or that printer, or that other computer even powered on and listening? How do you even check that? Well, the answer is a little thing called ICMP, which stands for Internet Control Message Protocol. And honestly, the best way to think about it is like sending a quick text to a friend that just says, "You there?" If you did a reply, you know they've got their phone on. In the world of networking, that's exactly what the ping command does. It shoots out an ICMP message and just waits for that reply. But ICMP is so much more than just a simple hello. It's also kind of the network's emergency messenger. So if you ever try to reach a website and get an error like "network is not reachable," that message is being delivered by ICMP. It's an absolutely crucial tool for figuring out what's going on or what's going wrong on the network. Okay, so we've confirmed a device is online. That's step one. But now, how do we create a private, secure path to it, especially when we're going over a public network like the internet? Well, this is where we need to build what's called a digital tunnel. We build these tunnels using a protocol called GRE, or Generic Routing Encapsulation. GRE's whole job is to take one of our data packets, wrap it up inside another packet, and then send it to a very specific destination. What this does is create a virtual point-to-point link, a tunnel that cuts right through the public internet. It's really the foundational tech behind a lot of VPNs. And the process itself is beautifully simple. You start with your original data, right? GRE then encapsulates it, which is just a fancy way of saying it puts your data in a new digital envelope with a new address on it. This new packet zips across the internet to the tunnel's other end, where it gets unwrapped or decapsulated, and poof, there's your original data, safe and sound. And here, right here, is the really crucial part. GRE builds you a private tunnel, sure, but the data traveling inside that tunnel, it's completely readable. It's like having a private tube system between two buildings, but sending all your secret messages on open postcards. Anyone who can get into the tube can read the postcard. We've built the road, but we don't have an armored car, yet. So how do we secure the actual data inside our tunnel? Well, that brings us to the next layer in our security stack, IPsec. This is the protocol that basically gives us the lock and key for our digital tunnel. IPsec stands for Internet Protocol Security, and it's basically a whole toolkit that solves the security problem GRE left us with. It gives us three critical things: confidentiality, which comes from encryption so nobody can read our data; integrity, to make sure the data wasn't messed with along the way; and authentication, to prove the data actually came from who we think it came from. Now, before any data actually gets sent, the two ends of the tunnel do this kind of complicated negotiation called the Internet Key Exchange, or IKE. Think of it like a two-part secret handshake. In phase one, they set up a secure channel just so they can talk privately. Then, in phase two, they use that private channel to agree on the exact encryption and keys they're going to use to protect the real data. What's really interesting here is that IPsec itself has two main parts. You've got AH, the authentication header, which just makes sure the data is legit. But the real heavy lifter for primacy is ESP, the encapsulation security payload. As you can see right here in the table, ESP is the part that actually encrypts the data, which gives us that confidentiality we desperately need. So we've decided to use IPsec, and we know we're using ESP for the encryption. But believe it or not, there is one more choice we have to make. How do we want to apply this security? And that brings us to the choice between transport mode and tunnel mode. And this difference is absolutely critical. So look over on the left at transport mode. It only encrypts the payload, the actual data itself. The original address information is still visible. But now look at tunnel mode on the right. The entire original packet, address and everything, gets encrypted and then wrapped up in a brand new package. This is huge because it means anyone snooping can't even tell who was originally talking to whom. So the bottom line is this. Because it hides not just what you're saying, but also who's talking and where they are, tunnel mode just offers a much, much higher level of security. It's really no surprise that pretty much all modern site-to-site VPNs use tunnel mode by default. It is the gold standard, for sure. So let's just quickly recap our journey here. We started with ICMP, that simple ping that just checks for a sign of life. Then we used GRE to build the private road, our tunnel, right across the public internet. And finally, we brought in IPsec to be our armored truck, using ESP in tunnel mode to protect our precious cargo as it traveled down that road. So, as you can see, each of these protocols plays a vital role, layering on top of one another to create the secure connections we all rely on every single day. And that leaves us with one final thought. As our world gets more and more connected, and the threats out there get more and more sophisticated, how will these fundamental security layers need to change and evolve to keep our digital conversations private?